So this is a set of multiple choice questions. They're all based on the amount of substance topic. They're all past paper questions and they're all AQA A-level. This is the fourth set in the series of amount of substance questions. And I'm going to recommend, as always, that you pause on each question, try and come up with the answers yourselves and see how you do with them. So let's start with the first question. And we have quite a lot to think about here, so we're jumping straight in with one of the trickier examples. But actually, we have been given a volume and a concentration of one substance and a volume and a concentration of another. So let's work those out. Let's do the MBRN. My concentration is 0.4, my volume is 20 over 1,000 because I'm converting to decimeters cubed, and I know that I've got 0.008 moles of the MBRN. And then if I do the same with the aqueous silver nitrate, here I've got my 0.1 multiply 160 over 1,000, giving me 0.016 moles. Now, in a normal question, that would be generating marks, but remember this is multiple choice, so we're leading to that one final mark at the end. It does mean that I can start to look at mole ratios. So my MBRN 0.008 reacting with 0.016 of the AgNO3. I can simplify that ratio. I have a 1 to 2 mole ratio there. It's also important that I remember that the test for halide ions involves making the insoluble silver halide precipitate, the formula of which would be AgBr, the cream precipitate in this case. Now, if one silver combines with one bromine, and I know that my MBRN is in a 1 to 2 ratio with AgNO3, then it's actually MBR2 that I'm going to be working with, because my MBR2 will yield 2 Br minus ions, which gives me 0.016 moles of Br. Next question for you to have a go at. This is about as straightforward as they can get, really. There are no tricks here, no nasty surprises. This is an empirical formula calculation. Put your elements in the top. We've got our M, Mr, in this case AR, N, and ratio. Remember, don't get mixed up with reacting masses questions here. Now, the 26 has come straight from the question, and I can work out that if 26% of my nitrogen oxide is nitrogen, 74% is oxygen. I now take my MRs, 14 and 16. That allows me to work out my number of moles, M over MR. I get 1.86 and 4.63. In an empirical formula calculation, my ratio is calculated by dividing by smallest. That takes me to 1 to 2.5, but we want whole number ratios, which is 2 to 5. So my correct answer is C, N2O5. Next question, have a go at this. So not as straightforward as it might first appear, but we have got a concentration and we've got a volume. So let's work out the number of moles. N is CV, which is 2 times 0.1. I've converted my Cm cubed to Dm cubed, giving me 0.2 moles. Now I then want to work out the volume that I would need to add to get to a concentration of 1.5 mole, Dm to the minus 3. So let's do my V is N over C calculation. I've got my number of moles, 0.2. I've got my desired concentration, 1.5. And that will give me a volume of 0.133 decimeters cubed. I can convert that to centimeters cubed. And you might think that isn't there as an option. But this is not about the amount that we are going to have. It's how much we need to add. And we've already got 100 cm cubed. So we're going to add 33 more, or that's a little rounded, 33.3 more. Correct answer is B. Next question, have a read through, see how you do. So let's break this down. Let's go right back to basics and see how much we can find out. Same volume, same temperature, and same pressure. Now, this is all making us think, hopefully, ideal gas equation. And let's just highlight the things that are staying the same. Well, P V and T are all constant according to the question, and R is a constant. So if everything there is the same, N must also be the same. So with that in mind, we can go to flask B and we can say that N is M over MR, and we can rearrange because MR is M over N. Now my mass is 0.34 grams because I'm converting my milligrams by dividing by 1,000. So 0.34. And my number of moles, as we've established using this equation, is the same as in flask A, 4 by 10 to the minus 3. So that allows me to work out that the MR is 85. Technically, it's 85.0. What I then need to do is start working through the compounds, and I can see CH2Cl2, 12, 2 1s and 71 takes me to 85. I've found the correct answer and we're done. That takes us to the end of this video. Thank you for listening and goodbye.